This is just a short introduction to electrochemical cells in grade 9 science. An electrochemical cell involves the conversion between stored chemical energy and electricity. Normally, we have two main parts to consider: the electrodes, which have to be composed of two different metals, one being the anode, which gives up electrons, and the other being the cathode, which accepts electrons. The other part that we need to be concerned with is the electrolyte solution. Because we're conducting electricity, this must be an ionic solution, and it allows the electrons to move between the anode and the cathode. So if we take a look at a simple electrochemical cell, this would be our anode. I've chosen the metal zinc, and it is in an electrolyte solution. The cathode, I've chosen to be copper, again, two different metals, and it's in its own electrolyte solution. There's a salt bridge in between, and the salt bridge actually allows for other ions to flow back and forth. The electron flow, as you can see, is from anode to cathode.
Hi, grade 9s. I just thought I'd make a little screencast video using this online web tool, and I'll provide you the link as well so you can play around with it a little bit at home. But because we can't do labs in the classroom, this is kind of the next best thing for us to do. So on here, you'll see that we have the starting of an electrochemical cell or a voltaic cell. It's telling you right here that you're going to click on the metals tab to pick one metal strip to connect to the black wire, which would be the negative electrode, which is the anode. So I am going to pick zinc, just because. I am then going to choose my solution, so I'm going to pick zinc nitrate since I have a zinc electrode, and I'm going to choose my molarity. Molarity means the concentration of the solution. So if you remember back in chemistry, we talked about how concentration of reactants can change the rate of a reaction. That'll come into play here. So I'm going to keep this just at 1 molar, and then I'm going to come over here. I'm going to choose a copper electrode. So I have to have two different metals, and because I have a copper electrode, I'm going to choose copper nitrate as my solution, and I'm going to keep that here at 1 molar. So I'm going to come over here and I'm going to turn this on, and what you will start to see is that we have a voltage running up here. So we have electrons that are leaving this anode, and they are going up through the voltmeter, and then they are coming here, which means since we have moving electrodes, or electrons rather, that means that we have a current running through the system. Now what's really cool about this is we can actually look here at the molecular level. So I am going to click on this, and if we look here, this is what's happening at the anode, and this is why batteries run out. Because if you notice, as the electrons leave the anode, that releases zinc ions. So we normally have zinc atoms as part of the anode of the electrode. The electrons leave, and that gives an ion, and the ions are soluble in water. So look at what's happening here. If I play this one more time, we can see that the anode is actually starting to degrade. And that's what happens when a battery runs out, is the anode has actually degraded to the point where there's not enough electrons to donate, and so current can't actually flow. So we're going to go now over here to the cathode, which in this case is copper, and we actually see that the opposite is happening here. Because this is gaining electrons through the circuit, the copper that was actually in the electrolyte that's part of this is combining with the electrons and forming copper metal. So if we watched over time, we would see that the cathode would, or the positive electrode, would gain mass. It would look like there was more material, and the anode would degrade. So that's the overall look of an electrochemical cell.
Now, the voltage in an electrochemical cell can be altered by changing a few different variables. One of which is changing the metals in the electrodes. Another is changing the concentration of the electrolyte, and by changing the surface area of the electrodes that are exposed to the electrolyte solution. Okay, so just looking a little bit closer at each of these, changing the metals in the electrodes, what we are talking about here is having two different metals and having different pairings. In each of the examples that I showed you, we had zinc and copper paired together, but in reality, we could have a variety of different metals and each will produce a different voltage. You'll learn more about that in high school chemistry. If we look at changing the concentration of the electrolyte, this is similar to looking at chemical reactions and knowing that if we increase the concentration of reactants, then we can increase the rate of the reaction. Similar here, if we increase the concentration of the electrolyte, we will usually increase the voltage of our electrochemical cell. And finally, if we take a look at changing the surface area of the electrode exposed to the electrolyte, this means perhaps having more of that metal submerged into the electrolyte, which then exposes more of the metal to the electrolyte, allowing for more donation of electrons. And that, grade 9s, is your simple introduction to electrochemical cells.